Welcome to Joystick. You are going to learn to write a Python program that will insert a node in a linked list at three positions: at the beginning of the linked list, at the end of the linked list, and after any specified position in the linked list. I have already created a video on how to code a linked list in Python. You can watch it to brush up your concepts by clicking on the I button, or you can access it from the description box as well. I'll switch to PyCharm now where I'll code this program, but before that a humble request to you to subscribe to my channel and hit the bell icon, as that way you will be notified whenever I release videos like these in the future. Let's switch to PyCharm now. So this is my PyCharm IDE in which I have created this file in which I'll write the Python program. If you are following along with me, then I recommend that you create a project and create a file in which you write the program with me. First, you will create a node class which you will use to create the individual elements of the linked list, which obviously are called nodes. So you will write class and then you are going to name that class as node. Within this class, you are going to first write the init method. So for that, you'll write def underscore init. There you go. PyCharm has done the work for me. And you will mention a parameter variable over here, which will be called value. Within the init method, you will initialize a field data underscore node to the value variable, which is being passed as a parameter to the constructor while creating the object of the node class. So you will write self.data underscore node equal to value. Within the init method of the node, you won't be initializing the pointer to the next node because you will be writing functions to set up the pointers of each node. So for that, you will initialize the pointer of the node to none. This data field next will hold the pointer to the next node. Now it's time for you to create a linked list class which will actually create the linked list. The functions to insert the node at any position will be written inside this class. So you will write a class and you will name it linked list colon. You will also write an init method inside it. So it will be def, init will appear automatically. That's it. And then you will write a line of code which will be self.head equals to none. So what happened here? In this class linked list, you are creating an init method too, within which you are initializing the head field to none. This head denotes nothing but the head node of the linked list. Currently, you are initializing it to none because you are going to initialize it using the linked list object. That means at the time of the object creation. Doing it so is going to give you more freedom as a programmer to maintain or create the linked list. It's now time to write the function which will add a node at the beginning of a linked list. The algorithm for which is simple. You have a linked list already, of which there must be a head node already present. This new node's pointer will point to the head node and you will make the new node, this new node of the linked list as the head node. That's the algorithm to add a node at the beginning of the linked list. For that, you will write a function def, let's call it add underscore begin underscore ll, and it will accept the new node as the parameter. So this function is accepting the entire new node as the parameter. In the next line, you will write new node dot next equals to self dot head. This line of code is setting up the pointer of the new node to point to the head node of the linked list. And then in the next line, you will write self dot head equals to new node. This line of code is making the new node, which has been passed as the parameter to this function, as the head node of the linked list, just as I mentioned. That's it. The function to add a node at the beginning of the linked list is over. Now you'll write the function which will add a node at the end of the linked list. So you will write def keyword and then let's call this function as add underscore end underscore ll, and this function is also going to accept a new node as the parameter. Here the algorithm will be to traverse to the end of the linked list and then set the pointer of the last node of the linked list to point to the new node, and then set the pointer of the new node to null. Why null? Because there are no more nodes ahead. First, you will have to check if the linked list is not empty. If it is empty, then you will make the new node as the head node. So for that, you will write the code as if self.head is none. So basically you are checking here if the linked list is empty. If it is empty, then the new node will become the head node. So for that, this code will do the job. And then finally, you will exit the function. Now you'll write the main logic to traverse to the end of the linked list and then add the node at the end of the linked list. So for that, you will create a temp node followed by an equals to sign, and then you'll write self.head. So this line will assign the head node to the temp node. Next, you will create a while loop, and this while loop will have a condition as temp.next. And then within the loop, you'll write temp equals to temp.next. So this while loop is going to run till the time it doesn't discover that the next node is null. In the next line, you will write temp.next equals to new node. So now when the last node is discovered, this line of code will set the pointer of the last node to the new node. Now, as I mentioned earlier that after we have set up the pointer of the last node of the linked list to point to the new node, we'll have to set up the pointer of the new node to point to null. But when you create a node, the pointer of the node is already initialized to null. So we need not do it explicitly. That's it. The function to add a node at the end of the linked list is also over. Now you will create a function that will add a node at any given position in the linked list. This is a tricky code, but once written, it's easy to understand. So let's start writing it. So you are going to use the def keyword. I'm going to call this function as add specific. The first parameter that this function is going to receive will be the position, and the second parameter will be the new node. So this position is going to contain the given position after which the new node needs to be added inside the linked list. Now the next line of code will be to define and initialize a counter variable. So let's do it first. I'll call it counter and I'll initialize it to 1. So initializing a counter variable here is necessary because it is going to keep incrementing to record the position of each passing node. You will understand it in a while why I did so. The next line of code will assign the head node to the temp node. After this, the loop will start, which will run till it has either reached the end of the linked list or it has hit the node at the given position, after which you will add the new node. So let's start the loop. So you will write while, and the condition will be temp.next. All right, I forgot to write the line of code that is going to assign the head node to the temp node. So it will be temp equals to self.head. Now you will write a line of code that is going to check if the position of the current node matches the position given. That is the position that has been passed as the parameter over here. So for that, you will write if counter double equals to sign position colon. So you can see that we initialized the counter as 1 over here. Had the given position been 1, then the execution is going to get inside this if else, specifying that the new node needs to be added after node 1, and this counter variable will keep incrementing. We'll write that code in a while. Within the if else, you will write new node dot next equals to temp dot next. So what this line of code is doing, it is setting up the pointer of the new node to point to the node which the current node, that is the node at position 1, is pointing to. So let's say if the position is 1, for example, and in the existing linked list, node 1 is pointing to node 2. After this line of code, the pointer of the new node, that means this node, will start pointing to node 2. In the next line, you will write temp dot next equals to new node. This line of code will set the pointer of the current node, that means the node at position 1 in our example, to point to the new node. So in our example, the pointer of node 1, which was earlier pointing to node 2, will now start pointing to the new node. Finally, you will write the break statement. Because once the node is added, there is no point in running the loop further. So the loop is going to break here. But if the counter doesn't match the value in the position variable, then what will happen? For that, you will write the code in the else part. So you will write temp equals to temp dot next. Let me change its position. And in the next line, you will write the code to increment the counter variable by 1. So this line of code states that the loop will keep running. The next node will be assigned to the temp node and the counter variable will keep incrementing. That's it. You have just completed writing a function that will add a node at any given position in the linked list. You will also create a function to print the linked list, the entire linked list. The code will be similar to the code which you wrote in the function above over here. So let's write the whole function. So you are going to use the def keyword and let's call this function as print underscore ll. Within brackets, there won't be any parameter this time. First you will write a nice message within the print function. So it will be the linked list and then the sign. And then you will mention a separator. So it will be space. That's it. Now you will write the same line of code which you have written over here. So let's copy and paste it. And then you will write a loop. But this time the condition will only be temp rather than temp.next. Since you have to print the value of the last node, hence this time the condition will not use temp.next. So you'll write colon. And within the while loop, you will write print and then you'll simply write temp dot data underscore node because you are printing the value. And this is the field which contains the value. And then you'll keep the separator as a space. After this line of code, you'll copy and paste this line of code. So it will keep going to the next node in the linked list. That's it. You have just written the function to print the linked list. Now let's create the main function, create the linked list and start checking the functionality of the program. So for that, you'll simply write the main keyword, watch the indentation and the PyCharm is going to do the rest of the work for you. Now you will initialize the linked list object. Let's call it ll followed by n equals to sign and then it's going to be simply linked list. Then you will initialize the head node. So it will be ll dot head and then you will assign an object of the node class and the value of the head node. Let's pass it 2. You can see that we did it externally. You could have simply called the add underscore begin underscore ll function that we created above, because this function is going to create the head node of the linked list, or in other words, it will simply add a node at the beginning of an empty linked list. So let's comment this out and use that function. For that, I'll call it my node followed by n equals to sign and I'll use the node class, pass 2 as its value. Now I'll simply use the linked list object to call the add underscore begin underscore ll function, and I'll pass the my node as its parameter. Now this should create a node in the linked list because currently the linked list is empty. Why not run the program and check the output? So I'm going to click on the play button. But first we'll use the linked list object to call the print underscore ll method. Otherwise it's not going to print the linked list on the console without calling this method. Now let's click the play button. There you go. You can see that the linked list has been created with one node, and this is the head node, and we have used add underscore begin underscore ll method to create the linked list. Now you have seen that we have created our linked list with 2 as the value of the head node. Now let's make use of the add underscore end underscore ll function. So for that I'm going to create a new node. I'll call it my node 1, and then let's use the node class, and the value of the new node I want is 3. Now I'll make use of the linked list object to call the add underscore end underscore ll function, and I'll pass this new node as its parameter. The print underscore ll function is in its place, and what I'm expecting is that there should be 2 nodes in my linked list. Node 1 will have the value as 2 and node 2 will have the value as 3 because we are adding this new node with value 3 at the end of the linked list. So let's run this program. So I'm going to click on the play button. All right, it hasn't added the new node at the end of the linked list. What's the issue? Let's go to the add underscore end underscore ll function. So I have intentionally written this line of code inside the while loop because I have seen many programmers make this mistake. Since we are traversing to the end of the linked list, hence this line of code will be outside the while loop. So the indentation is important over here. Now let's run the program again and check if this gives us the correct result. There you go. We have added the new node with value 3 at the end of the linked list. Now let's add a node between the 2 nodes. That means between the node with value 2 and the node with value 3. So for that, I'll initialize a new node. I'll create a new node. I'll call it my node 2. And let's give 5 as the value of this node. And I'm going to call the add underscore specific function. I'll use the position as 1 because I want this new node to be added after node 1. And I'll pass this node, my node 2. Let's run the program and check the result. There you go. A new node with value 5 has been inserted between the node with value 2 and the node with value 3. Let's insert another node now after position 2 this time. So for that, I'm going to create another node. I'll call it my node 3. I'll use the node class, and let's give value 10 to this node. I'll call the add underscore specific function, and this time I want the new node to be added after node 2, so the position will be 2, and I'll pass my node 3 as the parameter. Let's run it and check. The node with value 10 must appear between this node with value 5 and the node with value 3. There you go. Job done. Okay, let's do a final test. Let's add another node, but this time at the beginning of the linked list. So I'll create my node 4, use the node class. Let's give the value to this node as 21. And then I'll use the linked list object to call the add underscore begin underscore ll function, and I'll pass my node 4 as its parameter. Let's run the program and check if this node with value 21 is added at the beginning of the linked list. Here you go. The program is working totally fine. So with this, we have come to the end of this video. I hope you enjoyed this program. I hope you wrote this program with me. If you have any doubts, any questions related to this program, then do mention them in the comment section. I promise I'll answer them. I look forward to helping you with programming and algorithms. And only for this video, goodbye and take very good care of yourself.